We're going to start to look at imaginary numbers in this lesson, and we'll first look at graphs to see where imaginary numbers first started to be talked about or thought of. On the axes below, a sketch of y equals x squared is shown. Now consider the parabola whose equation is f of x equals x squared plus 1. So I actually already have that parabola graphed on Desmos, so I'm going to switch over to that. So here is the x squared plus 1. We see that whereas the x squared was down here with a vertex at 0, 0, this has a vertex at 0, 1. So let's go back to the notes and we'll sketch it. So here's my graph. And our first question says, how is the graph of y equals x squared shifted to produce the graph of f of x? So we see that basically the graph moved up 1. So now what can be said about the x-intercepts of the function y equals f of x? So this is our f of x, and we see that it has no x-intercepts, basically because the graph lies entirely above the x-axis. The next problem says, algebraically, show that these intercepts do not exist in the real number system by solving the incomplete quadratic x squared plus 1 equals 0. So we set our function equal to 0 to find the x-intercepts. It's an incomplete quadratic because it's missing that x term. We just have the x squared and the 1. So I can isolate my x squared and then take a square root. So up until this point, we know that we can't have negatives and radicals. So that's a sign that there is no answer in the real number system, which goes along with the graph that shows that it does not intersect. So just to finish solving this, we did take a square root, so I would get plus or minus the square root of -1, which is not a real answer. So we're going to look down the page and see how do we handle this, because there's a lot of parabolas that don't cross the x-axis. So it says, since we cannot solve this equation using real numbers, we introduce a new number called I, the basis of imaginary numbers. So this I is actually a number. Its definition allows us to now have a result when finding the square root of a negative real number. Its definition is given below. So I, the imaginary unit, is equal to the square root of -1. So here, when I said x equals plus or minus the square root of -1, that's the same thing as saying x equals positive or negative I. And I usually write my i's with the little tail, kind of cursive, so they don't look like ones, okay, in contrast when we're working with math. So let's start to look at some negative radicals. Having this I makes it kind of that we can fix any negative radical now. For example, when we do the square root of -9, I can always take a negative radicand, a negative number in a radical, and split it up into -1 times that number. So once I split it up, this is I, and the square root of 9 in this case is 3. So I have I and then 3, and we always write just like we wouldn't write like x3, we don't write I3, we would write 3i as our answer. Now, just a side note, I know we've been doing a lot of plus or minuses in front of radicals. This is a normal square root, okay? It's not something I'm solving. I didn't put that square root there, so we don't have to think about plus or minus here. So let's look at the next one. Now, you start to just do this in your head. So basically, I'll write it one more time on the side. So I think about this being the square root of -1 times the square root of 100, and the square root of -1 is I, so this is 10i, and you can just start to get the idea that you can just almost ignore that negative sign. The square root of 100 is 10, and then if you see a negative and a radical, you can just tack an I on the end of the problem. The next two questions are a little trickier because they're not perfect squares, but everything basically works the same. So the way I suggest writing these out, I'm going to take my perfect square, okay, which in this case is 16 that goes into 32, but I'm going to write -16 here. And then I'm going to write a 2 in the radical. So the square root of -16 we can find, and that's 4i. So I'm going to write this as 4i radical 2. Now for now, we're gonna leave that I in between the rational number and the square root. It can also go at the end, but for now, that's how you wanna write it. And then the delta math problems, that's how you have to write it for the ones we have today. So why don't you try the next one and pause the video and then come back. Okay. So this one here is going to be the square root of -9. My perfect square is 9, and I kept the negative sign there. And then the square root of 2. So the square root of -9 is 3i. And then I have the square root